have a problem with shoes.
Too many?
No, I don't have enough. Even though I have more shoes than my wife and my two daughters, who are both in high school, and my wife who teaches college combined. So I had to go yesterday. I gotta tell you, got this pair of Doc Marten bad boys.
Hey!
Yeah, these are bad. I tell you what, Tuesday morning around 11 o'clock is a really good time to go shoe shopping. So if anyone else is in, I'm going again Tuesday next week. So, yeah. Well, I have kind of a whole bunch of places, but you know it's bad when I have more frequent flyer cards to places than I do have credit cards. That's kind of a bad thing, but it's fun. You know, I love shoes, and you know, some people will say, "Well, how many shoes do you have?"
Too many. I don't know.
I'd say upwards of 45 pairs of shoes.
What? No way.
Seriously?
What's your cool
Yeah.
pair?
Whatever I'm wearing that day.
What's your? That's like good. Do you have like hooping shoes, like basketball shoes?
I got some basketball shoes, yeah.
I know this isn't how shoes hobbies.
But one of my favorite pairs of shoes, but they're not comfortable to teach in because I have to stand all day. I got this sweet black and white colored pair high top Vans. Dude, I love them. They're sweet. No.
Shoes. Like, do you have a mix and match? Like one shoe from this shoe?
No. I have them all categorized, sorted, in order, in my closet.
What are they categorized by?
Well, you have the brown dress shoes, then you have the brown casual shoes, then you have the black dress shoes, then you have the brown and black casual, and then you have the sneakers, and then there's the boots. So
You have like a walk.
Do you just have like a giant?
that's all that's in there. All right, so let's see what we have. So it was letter H, and it was every other even. What kind of questions did we come across on letter H?
10.
How much? 14. Number 14. So, problem 14, they have it listed like this. They want us to do g at x times h at x. Is this the one? And then I'm going to go ahead and list g at x over here. G at x, they tell us, is 3x to the 1/2, which is the same thing as square root of x. Right there. And then h at x. Am I doing the right one?
Yeah.
Okay. X squared minus 5x. Okay, so the thing that we really should take a look at, and we're just mainly looking at the domain for right now, is let's figure out the domain of the two originals, and then we'll apply it to this. So the domain of this one, we'll go square bracket 0 to infinity. The reason it's 0 to infinity is x to the 1/2 power is the square root of x. So I can have a square root of 0, which is 0. So that's my domain of the original. Is my domain of h at x restricted at all? No. So I don't have a denominator with an x. I don't have any square roots or anything raised to an exponent. That's not a whole number. So the domain of this will go negative to positive infinity. So something that we need to keep in mind is this. This right here has to apply to whatever we do to our functions. Whether we multiply, add, subtract, multiply, divide, we have to have at least that restriction. We can have a restriction that is greater, which means you use less numbers, but right now we can go from 0 to infinity. So we plug it in and we realize that, hey, now it doesn't work from 2 to infinity. 2 to infinity is more restricted than 0 to infinity. That's fine. If we go and plug it in and like, oh, look, it's no longer restricted. That's incorrect. We have to keep the original restriction. So let's go ahead and do the math that they wanted us to do. So we're going to go 3x to the 1/2 power times x squared minus 5x. Is that okay so far? I think we could probably distribute over the parentheses. So I'm going to get 3x. Is that right so far? So half. Or wait, I'm off. Like basis, I had the exponents, so I get half plus 2. That becomes 2 over 2, so that's 3 over 2. Minus 5x. Oh, fiddlesticks. I'm off. This should be 5 over 2. I'm sorry. 5 over 2, and this should be 3 over 2. Okay, so question for you on this, and some of you that might be stuck on that. How did I get 5 over 2? I took 1/2 and I added it to 2. 2 is the same thing as 4 over 2. 4 over 2 plus 1 over 2 is 5 over 2. And then how I got the 3 over 2, this is really x to the first, which is the same thing as the 2 over 2. So I go 1 over 2 plus 2 over 2, which gets me 3 over 2. So both of those are still square roots. They just happen to be squared bigger numbers, things like that, to the fifth, to the third. So I would still say that my domain, which is from 0 to infinity, holds true. I don't see anything that would restrict it any further, but I have to take that one restricted domain from up top. Is that okay? You asked for a second one, I forgot what it was. 14, then 18.
You distribute the 3 to the 5 to 15.
Oh, yep. That should be a 15. Good. There you go.
Isn't 18 just 1?
Yes.
So 18, well, but we have to be cautious on a number 18. We have g at x over g at x. And then they told us that g at x is this. So this again has a domain that's restricted from 0 to infinity, right? So if I take one function over the other, g at x over g at x, this is just going to come out to 1. So you have to think about, what does this graph look like? What does the graph y equals 1 look like? It's horizontal at 1. But this horizontal line at 1 has to be restricted. So think about what this looks like. We would have this horizontal line like this at 1, but because we have a restriction here, it's here. So we have to say, yeah, we have this as our answer, and this has a domain of this. So that's my answer. Okay, cool? Anything else off that worksheet you would like to take a look at? Yeah.
10.
10? Okay.
26.
10, 10, 10. Number 10. F at x over g at x. And they told us that f at x on this one is x minus 3. And they tell us that g at x is 2x plus 1, right? So let's go ahead and list our domains for both of these. Domain on this one's not restricted at all. And domain on this one's not restricted at all. So now I'm going to take the two, one over the other. So we know that x can't equal -1/2 here. So my domain is going to go from -infinity to -1/2, rounded, and 1/2 to infinity. So here's the answer, and here's the domain of that answer in interval notation. Okay, how do we know that x can't equal -1/2? I plug -1/2 and I get 0 in the denominator. So it goes from non-restricted domains to now we have a restriction. The other one was we might have gone from restriction to non-restriction, but any else? I have time for one more.
26.
2-6. Plug in a function into a function. So I have f at h at x. Okay, and so let's determine, so we want f at x, which is x squared minus 1. And just for, that'll be my domain of that one. And then I have h at x that's also listed, which is this, x plus 4. So this has a restricted domain from -4 to infinity. Is that okay?
Yeah.
And -4 can be included. That's why I have a square bracket there, because I can have a square root of 0. That works. All right, so now, this is where it doesn't always make sense. So see if you can watch this. I'm going to worry about h at x. H at x, we said, was this. Agree? So what I'm going to do with that is I'm going to take my f at x function. So I have so that was my f at x function. There was an x in there. What am I plugging in place of where the x was? Yeah, root x plus 4. Okay, I'm rooting the whole thing, so the answer is going to become x plus 4 minus 1. So then I get x plus 3. That's a nice answer, but is the domain restricted?
Yeah.
Yes.
It is. We had a restriction on my original functions. So this has to have this same domain,
-4 to
-4 to infinity. Even though it doesn't, even though x plus 3 we know is just a straight line that crosses the x-axis or the y-axis at 3 has a slope of 1/1. That's fine, but it's now restricted because we had an original restriction. You can't take a restriction away once we have it in there. Okay, we good? All right, Will, you make sure your names are on those, or if you handed anything else in, and pass them on forward, please. So I taught another teacher's class. It was the same class, but another teacher. Sorry, I was cheating on you guys. I was just asked to cover because this teacher had to go home for whatever reason. So I printed up notes for this class, the same notes that I would give you guys. You would have thought I gave these guys, ice cream. They're like, dude, this is incredible. Do all teachers do this? I'm like, well, I do. But I didn't know. Do you guys like these notes? Or?
Yeah.
I figured if you didn't like them, they wouldn't be. If you didn't like them, I'd find them all over the floor. But yeah. Yeah, I keep seeing those kids in that class going, "You're our favorite teacher." I'm like,
No, it's so nice out we brought. So like I wore.
I mean, the thing is, we have all the notes already created, so it's. I don't need to go reinvent what we're doing. Was this all the homework for us?
Yes, sir.
All right. All right. So, let's take a look at what these notes have for today. Yeah, I don't know why some teachers opt not to do it. I think it's great.
Me too.
And I feel that you guys are very fortunate. We're in a school that we do have a nice allotment that we can pay for papers and good photocopy machines. When I first started teaching in Vegas, they gave us one 500 sheet thing of paper saying, make it last for the semester. And then second semester, here you go. And here's another one.
Also, we have like actual notices that are here like every day, whereas in like Los Angeles, I think they were having the teacher thing, where all the teachers were like protesting.
Oh, they're on strike. Yeah, good for them. Yeah.
What?
Hey, true, that's up.
Denver public schools should be going on strike soon. Yeah.
You get the newspaper every morning?
I do get the newspaper every morning. I'm still old school. I love reading the newspaper.
My parents get the
The newspaper
I
guy?
feel like 6 people in the entire like United States actually use a newspaper.
Yeah, I'm one of them. All right.
My dad says every day you have to sit down and read.
It's a good thing. All right.
At the end of the night.
Perform the given operation, state the domain. So first thing I want to do is let's go ahead and realize the domains on the originals are restricted. So that's 0 to infinity because remember x to the 1/2 is square root of x. And the domain here is not restricted. So we will always have that restriction on the problems that we're using for x to the 1/2. So if I add these together, I'm just going to get this. And that problem's done other than saying, yes, we still have a restriction of this. Okay? And then the second problem, we're subtracting it. Well, the only error that is made on this one often is this. And we just change these signs to both blue because I would have had to have distributed the negative over both. And this has the same restriction from 0 to infinity. Okay? So it's easiest if you start it and you find the restrictions of the original and then you apply those restrictions to the answer. Questions on either of those? moving
Wait, so
on.
with the second one, you have to like switch the order of the.
Well, because all you're doing is. Oh, wait. Oh, you know what? Dude, look over there for a minute. I made an error. It was g at x. It was x plus 3 minus 4x to the half. There we go. Sorry about that. Do you see what where I made my error? Okay, so can I plug the same domain into this? The answer is yes. The domain on this one. Sorry about that. This is why I run out of time in this class. I make all these errors and then get the 8th period. They're getting the best presentation because I don't goof up there. I'm just kidding. They're way smarter than you, so that's why. I'm just kidding. I'm just being a jerk. I'm sorry.
You got it.
You guys realize I have sarcasm.
No.
Everything you say I take serious. Well, that's your problem. All right. Same restrictions, yes?
Yeah.
Is anyone struggling with how I'm making this?
No.
Yes, a little bit.
It's just like the.
So how I'm getting it is because x to the 1/2 is the same thing as square root of x. So the smallest number I can plug in is 0. I can still have square root of 0. That's why I get the domain.
So you just have to follow both restrictions all the time.
So you're just plugging in 0 for x.
Yeah, I just usually when you look for restrictions, if it's something that's not grouped, 0 is going to be a really good starting spot. But if it's grouped, then you have to think, okay, if it's grouped to the 1/2, that's square root of grouped. What would I plug in? And that has to do with why it shifts. All right, so this first one, we're going to multiply these. I feel like we just did this as a problem in class. So I get 4x, that's to the first, add the exponent, so I get to the 3/2, plus 12, that's 12x to the 1/2. Okay, that still would be a square root of x, and then to the third, and that's still square root of x, so we still have the same restriction here. And of course, if you graph these, and you can either plug a restriction in. Some of the calculators will allow you to. What I usually do is I say adjust your window to know what your restrictions are. So you set your x x minimum was 0, and then your y maximum to x maximum to whatever.
So you just add those exponents?
Yeah,
So 1/2
because that's 2/2.
Yeah.
All right, this one. Help me out here. I'm going to tell you that your domain is more restricted on this one.
Oh.
Why is that?
Because you can't have a radical on bottom.
I can have a radical on bottom technically, but what is that radical on bottom? If I plugged 0 in, what does the bottom become?
0.
So my domain on this one, I'm going to make the sign big so you can. Why don't I include 0?
Oh, because then you get a 0 on the bottom.
You get a 0 on the bottom. So this one has a slightly larger restriction than that one. That one we include 0. This one we don't. All okay?
Yep.
Yes, sir.
Can I move on? Okay. So now we're plugging a function into a function. So we're still using our same domain. So square bracket, 0 to infinity, domain, negative to positive infinity. Okay, we're still good there. But now we're plugging a function into a function. So fg at x means I'm going to take this and I'm going to plug it in here. So I'm going to get 4. That was an x. Now I'm going to plug x plus 3 in. Okay. Okay, so now here's a question. X plus 3 grouped means it would shift over to -3. Agree?
Mm-hmm.
So which domain is more restricted? Square bracket 0 to infinity or square bracket -3 to infinity?
0 to
So
infinity.
so what includes more numbers?
-3 to infinity.
Negative. This has more numbers. Do you agree?
Yeah.
Does that make sense?
Yeah.
So is this one more restricted than that one?
0 to infinity.
So 0 to, so that's why we have to change this one to stay with our original 0 to infinity. Okay, do you see how the restriction could have been misconstrued?
Yeah.
If you don't find your domain in the beginning of your original functions, you're gonna miss the points on these. You have to realize it came with this restriction. This can't create a less restriction. Okay? This technically, if this was my original problem right here, this would have a domain of square bracket -3 to infinity. Okay? If this had been 3 to infinity, would that have been more restricted? The answer is yeah. Okay, so you're looking what's going to create less numbers that it can work. And then the second one, I'm going to take f at x. So I'm going to take f at x, which is 4x to the 1/2, and I'm going to plug it in for x. So I'm going to get 4x to the 1/2, and then plus 3. Okay? So again, this still has our same restriction on it. Doesn't get any less. All this one would do if I had graphed it, it would have shifted it up. So the range would have been affected, but they're only asking for the domain. Good stuff?
Yeah.
The better you get these restrictions down now, the easier it's really going to transition for other classes later. We good?
We're like halfway done.
Okay. 3x to the 1/4, restricted or not? What's the 1/4 power?
Radical, and then we got a 4 on
So it's the fourth root?
Yeah, that
Okay, so fourth root. Is the fourth root act the same way that a square root does?
Yeah.
So it's restricted. So this will have a domain from 0 to infinity. And then this one restricted at all?
No.
No.
Yeah. No.
Nope. So the domain here is just negative to positive infinity. The reason you find both is you want to make sure one's not, if one's more restricted than the other, you have to go with the most restrictive when you start doing an operation. So I'm going to take g at x, which is 16x to the 4th, and plug it in here. So I have 3x to the 1/4. This was my original f at x. This was the x, but I'm going to take g at x and plug it in. Oops, 16x to the 4th. Is that okay?
Yeah.
2, 4, 8, 16. So what's the 4th root of 16? 2. 4th root of 16 is 2 because 2, 4, 8, 16.
Yep.
What's the 4th root of x to the 4th? X. So this becomes 6x for an answer. I'll pause there for a minute. Can you make that math work?
Yes.
Does it appear that 6x is restricted at all?
No.
Not if you just look at it, but we have a restriction from above. So what's the restriction?
Fourth root.
My restriction is
0
this.
to infinity. Cube thing.
Okay? That's my restriction. Even though we lost the restrictions because we did some math, we have to make sure we keep it. All right. Next one, I'm going to take my f at x function, 3x to the 1/4, and I'm going to plug it in for x on the second function. So I have 16 parentheses raised to the 4th. There was an x there, but now I'm going to plug this in. Okay? So 3 to the 4th is 3, 9, 27, 81. So I get 16 times 81x. What's 16 times 81? Anyone got a calculator up? I can't do it in my head. Sorry.
1296.
1296?
Yes.
1296x. Is this one restricted? It doesn't appear that it is, but I have to take my original restriction. Domain from 0 to infinity. And there's that answer.
Didn't we do this on Friday?
Yeah. This was I, though, we were doing, right? We did H for homework, right?
Yeah.
If not, I gave you the wrong notes, and we just go with it. At this point, there's no reason to change. All right. Now I want to take a function and plug it right back into itself.
No way.
Way. So okay, so I'm plugging 3x to the 1/4 back into 3x to the 1/4. Okay, so do the math. Ew. Let's see.
Don't you get like
So that's going to be x, and then I get 3 to the 1/4 times 3. So that's 3 to the first, so that's 3 to the 5/4. That doesn't appear to be restricted, but, so watch this real quick. Which function was I using? Twice. The f's?
yeah.
Was the f's restricted up above?
Yeah.
Yeah, so this will be restricted here still. So the domain goes from square bracket negative infinity to infinity. There's that answer. Now we're plugging g at x into g at x. Was the original g at x restricted?
No.
No. So this one might not be restricted either. I can ignore the 0 to infinity. Why is that?
Because it's irrelevant.
Yeah, I'm not using that function. So I'm going to take 16x to the 4th and plug that into the x on another 16x to the 4th. Uh-oh. All right, so that's 16 times 16 to the 4th, which is some ungodly huge number. Then x to the power of a power, multiply the exponents.
X to the 16.
X is 6, yeah. And I don't know if I'd go work that out a whole lot. I mean, that could then, you could say, well, that's 16 to the 5th, x to the 16th. And this did not have a restricted domain. So negative to positive infinity is your answer. Yowzers. Do I want you to find out what 16 to the 5th is? No, I'm not looking for you to give me some 8-digit number you say off your calculator. Keep that. That's good. Now you get the kid who's like the math geek going, should I change 16 to 2 to the 4th, which brings the whole thing 2 to the 20th? Sure. Sorry if you're that math geek. I apologize.
So
Was that you back in the day? Low-key.
So after about first grade, I realized I shouldn't be the teacher's pet. And I still remember this like it was yesterday. Well, first off, I gotta tell you, you're gonna laugh with this, and I promise you this is the truth, and I could show you a picture of the name plaque. My first grade teacher's name was Mrs. Doobie. Now, if you don't understand that, ask your neighbor. They can decipher what the heck that means. Well, Mrs. Doobie's class and Mrs. Phillips' class got together because we were going to do a grammar lesson. And so we're all sitting there up front. You know, remember we all sit there on your knees. And we used to call it Indian style, but I guess some people got offended by it now. It's crisscross applesauce. But, you know, that was back in the day, so I don't know. Not saying it was right. I'm just saying. So we're all sitting there. And I just remember Mrs. Phillips. And Mrs. Phillips, she always looked like, you know, like the aunt that everyone wanted. She was just that cool person. Like, she was the teacher every kid wanted. Even though we had a teacher who was Mrs. Doobie, no one liked her. So, I remember Mrs. Phillips going, okay, who can tell me all of the syllables of the alphabet? Boom, my hand's up right away. What do you got, Chris? I don't know. And then Geneva Wu, who had spoke like 19 languages by the time she was 2, raises her hand. Yes, James. A, E, I, O, and U, and sometimes Y. That's right. Chris, do you understand now? I still don't know what the heck you asked. I just raised my hand because I wanted to look like the smart kid. And everyone realized he's dumb. That Sturf guy, he's dumb. All right. So state whether if this is always true. If it's false, give a counterexample. Do you think it matters which way I add two functions together?
Yeah. Not really. Yeah.
What do you mean?
So if I had like x squared plus 6 and I want to add it to x plus 8, does it matter which way I add it?
No.
I think this is always true. I like it. What about subtracting? Subtracting is going to be false. Why am I saying it's false here? Here's my counterexample. If I knew this to be like x plus 3 and this to be x minus 6, so if I subtract them one way, I get x plus 3 minus x plus 9. If I subtract them the other way, I get x minus 6 minus x minus 3. Okay, so you'd have to distribute. You would distribute this over, so this is going to make it change. So that has to be false. Okay, and it looks like I have things I could pull out on these, but I'm not going to. I think we got them right. All right. Doesn't matter which way I multiply two functions together.
No.
I don't think so. If I took x squared plus 4 and x to the 1/4 minus 8,
Same
if I multiply them, FOIL them, double distribute, I think this is always going to be true.
Division is false though.
A division is going to be false because the domains of those are different. So this one would be false. Do I need to make a counterexample? Yeah, I could have one of them be an x plus 5 and one of them be an x minus 2.
Nice.
Okay, in different domains. Cool? Done? Almost?
Yep.
Oh, plugging in a function to a function.
That's cash.
No.
That's going to be false. Okay? Because if I were to take x plus 2, and let's say I have x to the 3rd minus 7, if I take one of them, plug it in, I'm going to get one way this happening, and the other way I'm going to get this happening. So those are not the same. So that's false. And then, if I plug a function into a function, is that the same thing as that function squared?
Good.
So if I took, let's say I had x squared plus 2, and I wanted to plug it back into itself, I'm going to get x squared plus 2 squared plus 2. Is that all right? Which, if I do the math here, that's going to give me x squared, or x to the 4th plus 4x squared plus 4 plus 2. So that gives me x to the 4th plus 4x squared plus 6. Is that the same thing as me saying x squared plus 2 quantity squared? If I FOIL that out this way, I have to add 2 to it. That's a big, fat falsaroonie. That won't work. It's not the same.
We are done.
That's it?
Yep.
Yeah.
Dude, I got like 7 minutes to spare.
Yeah, tell us the story.
Oh, story?
Story time.
What's
all right.
homework?
Well, let's take a look what homework is first. I think it should be 8i.
Every other odd.
8i, and you know, I would think because we missed a day of school, we should probably do them all, but I'm not that guy. So we'll do worksheet 8i.
Odds.
You want odds? I'll do
Always
odds.
do even.
I'll do odds. That good enough? Everyone's good?
You should show them story of the video first.
What'd I do?
No, you should see his video.
What?